So once downloaded in the Google local app, just upload it in the notebook.
Okay. Just a drag and drop, or how do we upload it here?
Just here, click on this.
1 second, let
See
me
upload.
come back. Okay, files upload.
Sir, once done, please confirm this. Just confirm in the chat. Yes, madam. Chandra Sriharidan. Yeah. So read this file. In file equal to. Please do along with me. Diabetic underscore scores. Dot txt. First line is header. Separate that header.
In file dot read line
Read line.
header.
This is our header. Okay. I copy this code into chat.
Read just like
And observe my output, your output, both are same.
Why do we get that new line character at the end?
Which one?
The slash n in the output.
Because at each line ending, enter key will be pressed, right? The backslash n indicates like next line.
Okay, but that should show up, or it can we skip that
The
like,
data that is recorded, that will show.
okay.
So generally, whenever you are typing some data, if you press enter,
Yeah.
backslash n will be recorded. Suppose if you press a tab key, tab space,
Okay.
backslash t will be recorded. These are invisible characters.
Yeah.
Done? Yes. Murli done, Hari done. Next, read all the data.
for
The
data equal to in file
In
dot
file dot. Read lines.
read lines dot
First, confirm the number of records.
data.
20 records we have. Copy this in chat. There are 20 records. And once it is done, check the data. Yes, there are. Just see your data. What is the high level data type? List.
List.
Each line has a element. Each line is a string. At each line in the last backslash n is there. Okay. All of you got same output? Confirm. Yes. Now I'm going to separate these inputs and this output from each line. Inputs, outputs. Both are empty list.
Yes.
Write a loop
For
line
in data dot. Okay. W equal
I'm going to split each line.
line dot
Split.
dot lower.
Lower not required because we are interested about only numeric content.
Yes.
Dot split. Splitting based on com.
Okay.
Now each line is divided into list. W is a list.
Yes.
The first 5 elements I want to take. These are inputs.
Yeah. Input equal to input dot ins
W of colon 5. Each value I want to convert into float. Float of V for V in this list.
Why we convert this into float?
Because we need numerical computation, right? Each element is a string.
Okay.
Whenever you split line, each element will be string. But I need numerical computations.
Yes.
That's why I converted into float. Why not integer means we have decimal values here. That's why I converted each value into float.
Out.
Similarly, output variable I want to separate from each line.
Out equal to float of
W of -1. That is a string value.
we have to convert to float.
Simply convert into float. Now INS is a list. Out is a single value. I will append these two ins into inputs, out to the outputs. Ins dot append. Inputs. Append of ins. Do same thing for outputs. Outputs dot append of outs. I copy this for you.
Instead of append, right? If you just assign, right? Inputs is equal to ins and outputs is equal to out. Will that not work?
Every iteration that will old content will be replaced, right? Overridden.
Okay, got it.
Now do it, please. And check the once it is done, check your data. Inputs. All input variables. First one is age, BMI, blood pressure, glucose level, insulin level. Got it? Similarly, I am checking with output. So previous one is a list of list. Now this is just a list. All of you check and confirm me. I go to the next step.
Sir, can you share the diabetic score text file?
You want me to share the file to download?
Yes, sir.
Yeah, I will do. Just download it.
Thank you.
Come on, sir, waiting for our confirmations. They were done. Yes, Chandra, Murli, Divya. Yes. Yes, Praveen. Now I'm coming to the next step. Our first step. Step 1,
Y is equal to Wx.
input matrix. What should be the shape of the input matrix? First column,
One.
ones. Second onwards,
So, wait,
age,
BMI,
BP,
IM,
glucose,
IM.
iron. Totally 6 columns to be here.
Yes.
First I am preparing ones. NP dot ones of. How many ones I want?
Then now,
How many ones I want? I have 20 patients.
let the inputs
Len of data.
data. Okay.
Now check the ones.
You don't have the numpy declared.
Did not import NumPy here. Import NumPy as NP. We got 20 ones. Based on this, I am preparing input matrix x equal to np dot c. What is c underscore?
Yes.
Column stacking.
Columns.
Okay, first column
Once.
ones. Remaining column inputs. This is column 1. In the inputs, we have 5 columns again. Totally 6 columns.
C underscore columns.
np dot c underscore.
Okay. You C underscore column.
What is the shape? I have 20 rows, 1 column. All of you execute and confirm this out.
The caps matter here, like capital X, small x, does that matter here? Or,
Generally,
it should be
whenever we
case
are going
sensitive.
for NumPy matrix, the naming standard is capital letters.
Okay.
That is just by seeing this, you can understand, okay, that is a matrix. Naming standards.
Oh, got it.
Yeah.
Got it.
So C underscore is nothing but combining two different matrices.
Combining columns, you can say.
And
Is it
that's a function again in the NumPy.
Yes. Chandra Murli done.
So Sriyangar, here we are passing that input data, right? From there we are generating this. But what happens, right? The output, whatever the output we are diabetic score that we are getting, right? If let's say,
That is in separate matrix.
yeah. So now my question is, if we have to calculate that. So now only let's say we get an input file without the score. We just got only age, BMI, BP, GL, right? And now the requirement was to generate the score and then create a predictive analysis on that, on top of
So
that.
before that, we need to build model. Build model means we need to find relationship between inputs and outputs.
But we don't have the outputs derived yet. First, we need to derive the output and then build on top of it.
No, already outputs are there in the given data.
No, it's there in this data, but in general, right? If we have a
In
requirement to
general,
derive the output also.
if there is no output, We cannot train a model. We cannot build a model. In the
Okay, so
given
for the
data,
model, we should have the
yes,
complete data set.
yes. In the data, we should have inputs and outputs, but we don't know the relationship. First, we find the relationship based on the past data. Next onwards, if new data is given to you, then you will generate it.
Got it.
Got it?
So one question here, Shyam. The NPC underscore is joining a column to a matrix. Do you
Join
have
the column
anything?
to a matrix. Combining columns into matrix, just assume like this.
Correct. Combining column. So do you have anything called NP R underscore as well, combining rows?
No, 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 no.
No, the C.
We have C
C.
underscore only.
Okay, I got it.
C stands for columns or combined?
But
Column.
both has the same number of rows, right?
Both should have same
When you
number.
combine.
Yes. Here C for column. Full name is column stack.
Column stack. Okay.
Up to now, all of you got the same output. Check your data and verify your output.
Yeah. Array of, yeah.
Yes. Yes, perfect. Next, what is the step number 2?
Output.
Output matrix. What is the symbol for output matrix? We follow.
Wait.
Y.
So this is our step 2. Y equal to
NP dot
C.
C underscore for output.
Outputs is a single dimension, so that only one column will be.
Yeah.
What is the shape of it?
116.
20 rows, one column. All these are the outputs. Come on, do it, please.
Since we have only one column, still we need to specify C underscore.
C underscore. Because previously is a single dimension. Now I am making a single column matrix.
Okay.
Previously single dimension, now it will become double dimension. 20 rows, one column. Just to check the values of the Y. Now it is a column. Only one column we have. Once you got same, please confirm.
Yeah.
Right.
Now clarification here. So
Hmm.
previous step, right? When you say outputs, we got the same matrix, right? 20 by 1. Yeah.
20 by
So now again with the shape of y dot shape also we got 20 by 1. So now
Yes.
only the difference like NPFC, that's what we are adding here.
If you look into the outputs, what is this? This is a Python list.
Right.
Just a list is not a NumPy matrix. That is
Okay,
single
okay.
dimension. Now you are making this as NumPy matrix.
Okay.
Okay. Next step number 3.
Right.
Find weights. What is the role of weights? What is the role of weights?
Calculate this.
W is equal to X transpose.
Relationship between inputs and outputs. Okay. What it contains?
Is intercept.
Slope and interception.
Yes, intercepted slopes. How many slopes?
How many inputs like five.
5
5
slopes.
slopes. One intercept, 5 slopes.
Yeah.
Okay. That means expected shape.
6.
6 by 1.
6 rows, 1 column. Come on, make a function. Define weights. What is the formula? X transpose
X transpose
dot
of
X.
whole square.
So here function bracket, just give it.
X
Always better practice as function arguments use small letters. Okay.
small x. Okay.
For
We
this,
need linear algebra import, no?
Equals
we will import it.
dot.
This is left side expression. This is left side expression. What about right side expression?
Correct. To work inverse, we need that import,
We
right?
need it. We need it. We will import later. First, tell me expression.
X dot t
X transpose
t
dot.
y.
But I'm using small letters
Small
as
letters.
arguments.
Return
Import INV.
Oh, here we are using small letters.
Because function argument,
Parameters.
right?
Okay.
LINALG. Import. What is the function?
in
IN. I'm going to
return
First tally before testing. Tally the size. What is X size?
20 by 6.
20 by 6. Then what will be X transpose?
6 by 20.
6,
6 by
20.
20. Correct. What is the result?
6 by 6.
6 by 6. Go to the right side. X transpose size
6
6, 20.
6 by 20.
6 by 20.
Y size
20,
by
1.
20 by 1. What is the result?
6 by
6,
1.
1.
6 by 1. Again, if you multiply these two,
6 by 1.
6, 1.
6 by 1. The same expected, right?
Yes, sir.
One bracket. Come on, all of you do this. W equal to capital W equal to weights of capital X, comma, capital Y. Here spell mistake. All of you test this W and verify the values of the W. Verify the values of the W.
Then we have
6 by 1.
X
Shape of W.
Man, this is capital X. This is capital Y. Here function argument. We are passing capital X into small x and capital Y into small. Verify the error. Somewhere W is not defined. Where we use W, here we are finding where we are. Just a minute. Once again, W equal to
W of X, Y.
weights of X, comma, Y. What is the shape? 6
comma.
rows, 1 column. Okay. Come on, all of you do test this. Yes. Perfect. Yes. What is the next step? Step 3. Up to now, 3 steps done. Step 4. Evaluation of the model. So what is our problem, sir? Regression problem or classification problem? Regression. For regression, what is the technique? R square.
R square.
Define R square. What we need to pass? Y and Y cap.
Y
Before that, what I need?
Y cap.
Y cap.
What do you mean by what is our problem? How to
Target variable value is a continuous or not? What is our target value? What is the problem statement? Based on these inputs, I want to predict
diabetic score?
diabetic score. What are the values of the diabetic score? Value can be any numeric value, right?
Yeah.
So if the value can be any numeric value, we use a regression model.
Okay.
For the regression model, to test the model accuracy, R square will be the technique.
Okay. Okay. So based upon the data inputs, we will decide whether
Not
it's a
data
regression.
inputs, output variable, based on the output variable.
Okay. Based upon output variable, we will decide whether it's a regression model or other model. So for the
Yes.
regression, we will use the R square to evaluate.
Yes. What is the predictive equation? X dot W. Already W calculated. X dot of W. What is expected shape? Shape of X.
20 by
20 by 6. W shape.
6 by 1.
6 by 1. Result.
20 by 1.
20 by 1. Understood. Y cap ready. Y cap is predictions. We are passing original diabetic scores and predicted diabetic scores. What is the formula? 1 minus RSS divided by TSS. This is the formula. First, I want to find out RSS, sum of residual squares. Y minus Y cap. The difference between actual and predicted. Each value can be negative, each value can be positive. Square. For all these squares. Dot sum. Understood? TSS. Y minus Y dot mean. This is deviation.
Whole square.
For all the deviations,
Whole square.
square.
Whole sum.
For all the squares, sum. Now finally implementing the formula RS equal to 1 minus RSS by TSS.
In bracket. Not needed.
Finally returning
RS.
RS. Now test the value.
RS of
R equal to R square equal to
R square of
R square of Y.
no Y cap.
Y cap.
Y capital ना? Yeah.
Y original values.
Yes.
Y cap, your predicted
Yes.
values. Okay. RS. How much I got?
1.
1.
Hmm.
That means what is the percentage of accuracy?
1%.
100%. All of you do this. Chandra.
This also there.
This also tested.
Can you write that equation for RSS and TSS one more time? Sriram, that Y minus Y cap root square of sum, right? Can you write in the equation format the sum of, the paint you will write, right? The sum of Y minus Y cap. Did you
Look
get my
into this
point?
RSS formula.
Mm-hmm.
R square formula.
Yeah, this is what I want.
This is the formula.
Okay.
Elaborate this formula. RSS means y minus y cap whole square for all the squares sum.
Some.
And TSS y minus y bar. Y bar means mean.
Mean.
Y minus y mean whole square for all the squares sum.
I got it. Hmm. Now it's more understanding.
So that is. Now you start think that you're satisfied with the accuracy. Next client is giving you new patient's data.
1% is it's 100%, isn't it?
It's not percentage, it's a probability value. Probability 1 means percentage.
100.
Suppose I got result 0.85. Then percentage is
85%.
85.
Least little okay, less percentage. I got it.
1 minute. Okay.
So the probability never will be more than 1.0,
Yes.
right?
Yes. 0 to 1.
Yeah.
So, but in a real situation, is it possible to have a 100% accuracy for this?
No,
Okay.
not possible. This is manually we created data.
Algorithm predictive, right? Yeah.
Okay.
So what if my probability is 0.5? How would I know what would be the other model that I should follow? As of now, since
You
the
tested
output
with linear regression. Next test with non-linear regression.
Yeah, sure. Hello.
okay.
Still not satisfied, test with the decision tree.
Test with what?
Decision tree.
Someone is talking
Array,
behind.
you need to
అది
mute, please.
అది
Array.
మనది కాదండి రిబేట్స్ బ్యాచ్ ప్రాసెస్
Can we mute him? Oh, yeah, I think we're good. Yeah.
Just
What was the last one you were saying?
decision tree.
Decision tree. Okay.
Still not satisfied, go with random forest.
Oh my God.
Still
So
not
how many?
satisfied. In this way, different thousands of models are there, very regularly, popularly used.
So do you have any hierarchy or any preferences?
No
Which one?
hierarchy. So first,
So-
blindly we are testing with linear regression. Then we go with non-linear regression. Then decision tree. Okay. Then random forest. It's not a rule of the order.
So it's not even the it's now not even the order that we need
It's not
to do in
order
the
doesn't
real time.
matter in which way you are finding out.
Okay.
So finally, you will be experimenting with each model.
So what's the standard? What is the general real-time standard? They start with the regression and they'll move on, or
That is what I said. There is no particular standard.
okay.
There is no particular standard. So general basic idea in coming concepts you will be understanding. Look at what are all your input variables.
Input variables are the what do you call the
What are input variables in our
blood
case?
and pressure. Those are the input variables.
Age, BMI, blood pressure, glucose, insulin, right?
Yeah.
So all these are what continuous values or not?
Yeah.
If all values are continuous inputs, first I test with linear regression.
Okay.
Later I do test with non-linear regression.
So then I think it will be this case. First we will keep all regression models available, and with the different scenarios we will test all the models. We'll look for the best one, isn't it? It's not like building this regression models every time. Instead we'll kind of make a generic regression models for all the scenarios, and we'll convert the data into the respective matrices. Is that the
Yes,
case?
yes. And one more clue I am giving you.
Okay.
Suppose here there is a variable called sex.
Mm-hmm.
What is the nature of the sex variable?
Female. It's not
Classification or continuous?
it's not numeric.
That
It's
means,
not code.
forget about numeric. It's a classification or continuous?
Classification.
Classification. If input data is a mixed of, if input
And
data is mixed of continuous and classifications, that means
Mm-hmm.
categorical. Then
That
go
is what?
categorical.
Okay. Okay.
Then blindly test with the decision tree.
Decision tree. Got it.
Your first attempt only with the decision tree.
Understood.
Understand?
Understood.
Suppose if all input variables are categorical,
Mm-hmm.
then blindly test with naive Bayes.
Naive Bayes. What
Understand?
if? Okay, so then I think there is no, it will not make sense by adding the cities. Oh no, it will make sense. Let's say if I have some data with the city names or area names.
Hmm.
What about in that use case?
So what is the data?
I have some city name based upon city also.
City.
Uh,
Suppose if really city is controlling your salary or not, you just verify it. For example, in our case, the variable city doesn't impact on diabetic score,
correct.
correct? But
Yeah,
it may control your income.
correct.
Understand? In
Yeah.
this case, what I do is I transform cities into scores.
Okay.
Example, there is a Hyderabad, sir. There is a
Mm-hmm.
Pune, sir. There
Mm-hmm.
is my hometown Ongole, sir.
Mm-hmm.
Job is IT job, sir. Target variable is income, sir. Apply the score for it. No work from home option, sir.
Mm-hmm.
For Hyderabad, I give some 10 score. For Pune,
Okay.
I give 12 score. For
Mm-hmm.
Ongole, I give 1 score. Understand the point? If really
Got
city is controlling the target, then you have to transform cities into schools.
got it. So that scores again depends upon the
Uh,
salary ranges and different factors.
yes. Okay.
Okay.
On that way, like there are, because before trying the model, there are many data steps are there. First data
Okay.
extraction, after that, lot many other transformations are required. Okay. So we do.
Got it. Okay, so I understand on the linear regression, I understand on the decision tree, I understand when we have the cities, we will convert into
Mm,
generally the
mm,
respective course and all. How about the
mm,
dates?
mm.
Dates.
So that again, that is matters. If date is what date of transaction or the date of birth. If it is
Let's
date
say,
of birth, convert that date of birth into age.
no, no, not on date of birth, it's a date of transaction.
Date of transaction. Date of transaction is like placing role into this one. Which one? Whether date of transaction is a matter of your price or not, you just confirm it first. If it is date of transaction, suppose if date is also controlling the price of the transaction, transform them into how many days happened. Suppose that 2 days back one transaction happened, no, today is 20th, on 18th transaction happened. How many days passed? 2 days. Convert into two markets. Okay.
so,
That
Convert
is
into what?
Sriram,
What's the last statement convert into? So two
convert into
days?
number of days passed.
Okay, okay.
Okay. Suppose 18th transaction happened today,
20th.
20th. How many days passed? 2 days passed. On that.
so do we have a list of all possible models in the machine learning, uh,
Mm,
and their purpose of and their usage?
yes.
Okay.
Definitely. Definitely
Yeah.
we give you. Because we not
Yeah.
yet enter into the machine learning.
Okay. Got it.
Okay. So definitely I give because in the machine learning there are different models for supervised learning, different models for unsupervised learning. Okay.
Okay.
Again, reinforcement learning. This is a different thing. Disciplines are there.
Yeah.
And Bharat, I have one question here. So, do we have any tool which can suggest which model we proceed with based on the data?
That is what in Azure ML there is a process called Auto ML that is
Oh, okay, great.
especially designed for brainless data scientists.
Okay, good.
Understood, sir. In the
Good,
Auto
good
ML, you run
terminology.
it will do its own experiments. Finally, it will
Yeah.
select the best model.
Okay, yeah, sure. I got it. Thank you, sir.
Yeah.
Yeah, don't mind for too many questions, Bharat. I
No
think
problem.
going
No
forward,
problem.
yeah.
Yeah, you should have tell us there are some kind of a brainless models that
Brainless. Models have brain, but user need not to have brain here. Only
That's
user should
going to
have
be the
common
future.
sense. User should have common sense. Intelligence part will be taken care by the system.
SaaS model.
Yes,
That's the
SaaS
future.
model.
Now there's a new terminology given for that model, Sriram. It's called vibe coding.
Vibe coding.
Yeah, don't use your brains. Just use yeah,
Just
that's called vibe coding. Now everyone is looking for the not the SMEs. Everyone's looking for the vibe coders.
yes.
You should not say anything to no.
Simply vibing with vibe, that is.
Yeah.
Okay. Come to this one. So once we step into machine learning, a lot of other things you will enjoy. First, our target is
Testing.
already test completed. We got 100% accuracy.
Yeah.
Huh?
New entries.
New patients data I'm taking. Yesterday we created this one, right?
Four records.
So here 4 records. So I copy this file and all of you download this. New
Can you
diabetic.
share that path, like folder path?
Yeah, he'll.
Okay, definitely. Because here some my financial documents also there. I remove it and share with you. My personal files also here. After that, I
Oh, okay.
separate it. I will share with you. What is the file we just copied?
We'll also keep it personal, sir.
New patients. New diabetic patients.
So with this file, now we are trying to like add more predictor model.
Suppose client is giving you new patients data.
Okay.
So within that new patients data, only input variables are there. Client doesn't know what is a diabetic score target variable of.
Okay.
Just first download and upload into our collab. I posted in Zoom chat. New diabetic patients. Once done, just confirm. Yes. I am reading this P file, patient file. Open off. What is the file path?
Contents.
Content another new
Patients. New
diabetic
diabetic.
patients. We have header or not?
Yes.
We don't have header.
No.
No header. Okay. So I want to read all the data. P data equal to P file dot read lines because we don't have any header. Complete data we are.
Read data.
So all the 4 records have been read here. Right.
Yes.
Come on, execute this. Done. Any more confirmations,
We
please?
should match it to the original matrix, right? The original file that we
Yes.
upload.
Yes. Original input matrix X.
Okay.
First to separate all the patient ins.
For
Yes. Tell me.
for
For line in
feed
feed.
data.
Split it.
Line dot
Line dot
string
dot
splits.
split.
Comma.
Now everything is a string.
Yes.
Convert each into float. Float of V. For
V in line. Sorry, W.
for V in W. Every value is a thing. Add this to the pins.
Pins dot
Up and
out
down.
W.
Check the value of pins.
Array. Sorry.
Come on, all of you test this.
This dot.
I posted in chat. Hara Hara Mahadev. Done. And few more confirmations, please. Yes, Murli, hurry, done. Now, going to prepare matrix. This matrix shape, our original X matrix shape should be same. That means number of columns should be same. What is the first column? Ones. How many ones I need now? 4 ones. Okay, let's say P1 is equal to
MP dot ones len of P data.
Capital P predictable matrix. NP dot C must come. First column
P1s.
P1s. Next column P's. What is the shape of it? 4 rows, 6 columns.
4 by 6.
Correct? Come on, all of you do this. Done, hurry.
This
Prompt done.
collab, right? It automatically, gives us the code. It gives us the prompting as well. When we start typing this code, right? It gives the prompting for the next line of the code.
Because it is enabled with the generative AI.
Mhm.
Yes, Chandra Murli. Come on. Next, I want predictions. Diabet scores equal to. What is the predictive equation? X dot W. In the place of X, I am keeping P. Dot of W. Diabet scores. 4 rows, 4 patients data we are passing, so that we got 4 diabetic scores.
Yes.
That means 4 predictions we got it. Come on, test this.
We got the P. P is the new patients,
Hmm.
and W, what are the
W
weights?
old weight matrix. Already we find W right previously.
Yeah.
That one.
Hmm.
Now I want to submit this report to the client. First confirm it is done or not. Yes, Murli. Rom. Suman. Come on. I'm going to write the report to the client. np.c underscore.
So here W is the actual output. So the all other things are we are validating and we are making sure the
W is our weights. Previously, what we have calculated in the third step.
yeah, the weights of on the existing data, right? Based upon their
Yes.
inputs and outputs, what is the weight of getting diabetic?
Yes.
Yeah, yeah.
P is in the place of X, we kept P.
New patients.
That means new patients. So 4 rows are here. This is 4 by 6. This is 6 by 1. What is the size? 4 by 1. We got it. I want to combine the new patient's inputs and his predictions.
And diabetic scores.
Diabetic scores. Let's say a result. Diabet. Our matrix is diabet. Okay. Now check the result. This is the data.
Correct. 1/6.
Now along with the prediction.
Yes.
Come on, do it.
So we don't need to
How-
test
how
this
do
again, the probability, no? Why? Because we already doing.
Already we got accuracy, good accuracy.
Yeah. So is there any scenario that based upon obviously, right? So based upon the new patients also, the weights might change.
Yes.
So then how do we know? Yeah, yesterday already we have discussed based upon the attributes or
Experiment with model 1. Think that you got weight 1.
mm-hmm,
I tested accuracy. I got 80.
mm-hmm,
I tested with, I experimented with model 2. I got weight. Think that 99. What you will consider?
99 model 2
That means which one? Which
W2.
weights you will consider?
Yeah.
Weight 2 you will consider. Right? Like that.
No. So my question is, as we got the new patients, we are considering the existing weights, and based upon that, we are predicting the diabetic score for the new patients, isn't it? So let's say there will be scenarios based upon the new patients, even the probability can vary.
No probability vary. We don't know. We don't have scores. We have given only new patients data. You want to follow about the first statement? Your prediction is what?
76.45.
76. Suppose this is the statement you have submitted to the doctor, but a doctor really manually tested him,
Mm-hmm.
but his diabetic is 90.
Mm.
But what is our prediction?
76.45.
76, 90. But for the second patient, the prediction is that 66.95, but actually is when do you really test it? 66. After that,
Okay.
83. After that, 70. Let's say 4. Almost all predictions are close to predicted values. All real diabetics are close to predicted value except 90. That may be abnormal. That means majority of the predictions are good. For example, majority of the predictions are bad, then immediately doctor will ask you change the model. Your predictions are bad. Then you need to retrain the model by clubbing old data,
Test new data.
new data.
Yeah,
That's a good
that's what
question.
my question, right? When you get a new data, so there is a continuous process combining after we predict the score, new score, right? For the
Yes,
new data set.
yes, yes,
Will the old and new data set will be combined?
yes.
Okay.
Old data 1 lakh records, new patients 30 lakh,
We have
30,000
to do that data engineering,
Hmm.
Hari.
Yeah,
So
data.
when after new patients, if the scores are not meeting, so you have to
So
build.
that process we do at the time of rebuilding the model, not every day.
Okay.
The time of rebuilding. When you will rebuild the model, whenever your accuracy got decreased.
Correct.
Got it.
So when we want to rebuild a model, again we take the complete data set where we have
Yes,
till
all
today.
old history plus
Mhm.
recent history. That means recently, once model deployed onward, some new data generated, right? That data also.
Bharat, if you want to send to the client, right, the data, so if you want to add one more column like diabetic yes or no, right, so will you send like this only or add one more column saying yes,
Just
is
you
it,
can use np.c.
and the score level we have to define.
Yes.
Okay.
On that way, you can add number of columns.
And Bharat, how model rebuilding is different from model training? So, is there any difference or both are same?
Model training is one of the part of model building.
Oh, okay. Okay. It is
Model building
subset.
is a collection of different steps
Oh, okay.
like data extraction. Second, data cleaning, transformations. Next, data preparation, that means matrix preparations. Then,
Okay.
trial model.
No.
After trial model,
Evaluation.
after evaluating the model, because you are not testing with one model, right? You are experimenting with multiple models, right? Then
Yes.
model
Rebuilding. Okay.
selection.
Okay.
Modern selection ready for the production. After that, model selection.
If we get deployment, okay. If we
Deployment.
get any new data, then
Yes,
we will do model
deployment into
rebuilding.
production. Then deployment done. Then next what?
Monitoring.
Monitoring. Once deployed, if you keep calm, patients will die. Okay. Monitoring. Okay. So whenever you find that model accuracy got decreased,
Again rebuild.
then rebuild. The last page is rebuild. Again, rebuild means again work started from. Understand?
Got it.
So far we did till step 6, no? So far we did till step 6.
Till step. But we experimented with one model only.
Correct. So there can be multiple models, but those steps, at least with one model, we did so far 6.
Yes.
Right?
Like. New patients data, I got it. I want to write this result. First, confirm me, all of you got the same result?
Yeah. Yes.
Yeah. I want to write this result into output files. Out file equal to. Open. Give the path. Content.
Output.
/ ready to dead. .txt. First line header I need. What is the first field, sir? Age, age. Next, BMI. Next, BP. Glucose, insulin. In the last, I'm keeping.
Next time.
So that time actually this entire process we do with the partners. Volume maker, we do the same thing with the PySpark data frames in the database.
We need to add one more column, right? Diabetic scores also.
Yes, diabetes score. That's a D score. Got it? Write this out file dot write off. Right. Then perform a loop for patient P in result. So here each P is a numpy array. If it is numpy array directly, I cannot concatenate. That's why converting into list str of V for V in P. Now join dot join of L. In the last, what I want? Backslash. This line I want to write it. Out file dot write. After loop, close. Out file dot close. Check this. Print. Data written or not? Yes. Just check here. Now comment on the third patient. 57 age, 31 BMI, 134 BP, glucose 158, insulin 93. His diabetic score is 83.4.
Our model is working in the right. Our model is giving right result.
Model?
Our model is giving right result with scores.
Right scores. So these are the final. This information we upload to the patient, that means hospital management systems. Okay. So then how they believe you? How they believe you? Whether your generated report correct or not? Test. Think that you are not a scientist, you are head of your hospital. How they believe you?
Do we have to show our samples or the previous one
Suppose
average?
daily you are giving 100 predictions.
Okay.
So from the client side, one guy will be there.
Verify.
So he won't test all the things. Randomly, he will pick 2 or 3 patients and he will test it.
Okay.
Instead of testing with all the 100, think that a diabetic score test is 1,000 rupees. Daily he is again testing all the 100 patients, so that will be cost to him, right?
Yes. Randomly will test.
Okay. Randomly 2 or 3 patients he will pick it. He will test it and verify it whether his your prediction and his actual experiment is same or not. He will verify it. So on that way, as days goes on, what he will find is most of predictions are getting failed. Then he will report you. Then it's time to repeat. In this way, human intervention should be there. Human interference. Understand the point?
At the time of rebuilding, whole data will be done.
All old data plus new data.
Yeah.
You need to combine and retrain the model. At the time of retraining, if necessary, you need to change the model also.
Okay.
If necessary, you need to change the model also. Sir, I posted this recent code. Final step, do it and you can leave.
Data preparation is always in the matrix form.
Data preparation to be in matrix. Once done, confirm it, sir. Yes, wrong.
So though our source is in any format or any source, to do the modeling, it has to be converted into the matrix format.
Yes. Suppose the patient's data they are maintaining in MongoDB, sir. Whenever you extract the data into Python from the MongoDB, you get data in JSON format, right?
Yes.
That JSON you need to make it as a matrix notation. That's why
Right.
this is the third step is very crucial. The second step and third step. What is the first step in the cycle?
Matrix.
First step in the
Data.
cycle. Data extraction.
Yeah, data extraction, cleaning.
So for this, what you can use? I can use
ADF.
or data factory in the Microsoft Fabric. After that, I also derived content is JSON. I want to structure that JSON. Then I use either Databricks or Fabric. No. Finally, this is for clean and transformations. After that, matrix preparation. So matrix preparation here also we use Spark ML. If data volume bigger, data volume small, then directly they can use NumPy. Okay. So here for cleaning and transformation also, if data volume bigger, yeah, they use Spark. Small, directly they will use Pandas. Okay. Similarly, here you have Spark ML. Then train the model with Spark ML in the Databricks. Got it?
So the matrix whatever we are using. So we used X transport data of X and Y transport data of Y, right? That is the formula to do the linear regression.
Yes.
If you wanted to use a decision tree, we should have a different formula, different expression, and we have to
different expression. But in this way, as models are increasing, like we cannot remember all the things, and the logic implementation also, we will be stuck to implement all the things. That's why we use libraries.
Okay.
Spark ML is suppose scikit-learn is the one of the library. What is the style of scikit-learn? Within just 2 lines, our entire work will be completed.
Oh, yeah, that's where I'm going.
From sklearn dot models import.
It will give all the models.
Linear regression. Up to now, what is done? Model class imported. Then create model object. Model equal to linear regression. Then I want to train model dot fit of x comma y. So before doing this, you have to prepare the data. So mainly engineering work is more, scientist work is less. Understand?
So yeah, when we were preparing the X data, we were abiding with that one dot, right? Is that still needed? I mean, when I say one dot, we have the intercept point.
Yes.
The intercept is mandatory for all the models.
Yes. So, but for this
Intercept
one,
and
you don't
slopes
need to
are
worry
mandatory.
about whether you are keeping first column once or not. Internally, it will apply it.
Oh, okay. Okay.
After that, model dot intercept. What you will get? Intercept value you will be getting. Suppose you want slopes, model dot go x.
So when we are using libraries, we don't need to, kind of convert into interceptions. What we did.
Entire thing will be taken by this statement.
Only that, just X and Y format we have to provide.
That's it. Here, more messy. Suppose you are doing one model building work for 1 month. 27 days time will be killed by data preparation. So,
Oh, I got it.
So
got
80% of time.
it? Not 80%, 90% of the time.
98%.
Okay, that's why data engineer is hero here.
Understood.
Got it.
So you will be covering some examples with the sklearn as well in the
Yes,
future.
SQL, PySpark, all the things.
I got it. Yeah.
Okay. So for small volume, why I need to use PySpark? For small volumes, I go with SQL. For big volumes, I go with the Spark ML. Understand? So both the
Yeah.
things.
We should also understand how internally the data is being, weighing
So
and
just to have mathematical idea behind that, but don't go for pure mathematics. If you go like this, you cannot become data scientist. You will become mathematics lecturer. Okay. Just to have idea, like what this SVM is doing, how this decision tree works like that. And then directly implement the model. Okay. Later, very soon, after a few sessions, we will come back to the libraries also.
Yeah, today is the first fabric class, Sriram?
Today morning, first fabric class happened.
Okay.
Today morning, 7:30. Suppose if you miss, please collect that recording.
Yeah,
Is
sure.
Fabric is like the Databricks kind of thing, or like it's a
Same like Databricks, but Databricks comes under PaaS model, platform as a service model. Fabric comes under SaaS, software as a service. Right, sir. Thank you very much for spending time and happy weekend. See you on Monday.
Thank you, sir.
Thank you, sir, for explaining in
Right.
detail.
Thank you very much.
Thank you, Sriram. Happy weekend.
Thank
Good
you.
night.
Happy weekend.
Thank you.